All right, this video is for Calculus 6.2. It is on growth and decay. All right, so just a refresher from pre-cal and algebra 2. The equation for exponential growth, there are two numbers being multiplied. They will never be combined because the second number holds the exponent, okay? So that second number, if it's greater than 1, represents growth. And if you've taken my classes before, we talk a lot about money with these equations. And then if b is a fraction in between 0 and 1, it is decay. All right. This also appears a lot in Cal BC. We have a section that talks about logistics growth. Okay, so if you take BC next year, you'll learn that as well. Now, the two equations you're going to see for this lesson, they, I don't want to call them the same thing. This first one is the function written as a rate. If we were to do the antiderivative of this, we would get this equation. Okay? And this equation here, you have seen it before, but with different letters. You saw it in pre-cal and in algebra 2. Some of you might remember the acronym PERT. You guys remember this? Okay, so the P stood for the initial amount. E is literally the function E on your calculator. R was for rate, and T was for time. So if you remember that from algebra 2 and pre-cal, hopefully you can make the connection that here C, like P is, it's your initial amount, okay? So before we talked a lot about money, we're going to start talking about other things like population and animals and things like that. So if they ever give you an initial amount, you can do the math and solve for C, or you can have that understanding that C represents the initial amount, okay? You can fast forward through that step. E, again, is the function E. K is in the same spot as R. K is going to be your rate. You're going to have to solve for that one. And then T is going to be your time. Okay? So let's slide over and look at this first example. So in this first question, they tell you that the rate of y is proportional. And I'm sorry, I think I forgot to mention it. Up here I put keyword. The way you know to pick this equation that I put a star on, which you should have memorized by the end of this chapter, is the word proportional. The moment you spot that in a word problem, that is your red flag that we are going to use this equation right here. Okay? So this question says the rate of y is proportional to y. I believe I made a mistake there. Give me 1 second. All right, everything is as it should be. So then it tells you when t is 0, then y is 2. What they're starting to do here is they're starting to give you ordered pairs. So the first ordered pair that they give you is 0, 2. And then they say that when t is 2, y is 4. So there's your second ordered pair. And then they ask you, what is the value of y when t is 3? Okay? So you always want to use the one that has a 0 in it first. Okay? So again, my x is like my t, and my y is just my y. So I could say 2 equals c e raised to k times 0. Okay? So what is 0 times k? 0. E raised to 0? 1, right? Anything raised to 0 is 1. And then 1 times c would just be, so you can see that c is equal to 2. Okay? So you can do that by plugging it in mathematically. Or, like I said, anytime they tell you time is 0, and back when we practiced motion a chapter or two ago, we said when t is 0, that's your initial amount. So you could also see that whenever you have this ordered pair with a 0, that your c is just that y value. Two ways of seeing it: plugging it in and solving for it, and your shortcut. So we could even make ourselves a side note, if you guys want, next to your formula that says initial amount. Okay? All right, so now that I know what C is, I can plug C into the formula. Okay? So when I go to plug in this next ordered pair, not only do I know T, which are giving me 2, not only do I know Y, which are giving me 4, but I've already solved for C. Okay? So on my next step, I could say, if Y is 4, I could say 4 equals, I found C so I can plug it in, e raised to k, and for this ordered pair, they're telling me that t time is 2. All right, so now that I only have one variable left, k, I can solve for it. My goal right now is going to be to isolate it. We're going to need some tools that we learned in Algebra 2 and Trigger Pre-Cal to be able to get that k by itself. So step 1 is that I'm going to divide both sides by 2. Okay. So now I have 2 equals e raised to, and I'm going to put the 2 in front of the k just because I'm used to seeing my coefficients in front of my variables. Okay. Now, who remembers what I can put in front of that e to move that 2k out of the exponent spot? ln. So I could put an ln, but if I do it on one side, I have to do it to the other. And then I'm allowed to move this 2k to the front. Okay? So now I have ln of 2 equals 2k times ln of e. Good. And ln of e equals 1. So what I really have is ln of 2 equals 2k. And what would be my last step to get k by itself? Divide by 2. So I could say that k equals, you could say ln of 2 over 2, or you could put half ln of 2. Okay? All right, so if we read the last sentence of the question, it says, what is the value of y when t is 3? So now that I know what c is, and now that I know what k is, I could plug those in, plug in the 3 for t, and I can solve for y. So we're on our last step now. Okay, last step is to say y equals, I found c to be 2, times e raised to, k is, right, half ln of 2 times, and my t is, they're asking for what is y when t is 3. Okay? And at this point, you could either leave that as your final answer if it's a free response question in the AP, or, okay, you go ahead and go onto your calculator and plug that in. So here's a peek at what your calculator should look like. Okay, and you get 5.656. I'm going to encourage you not to round if you're taking the AP calculus test. They give you full credit for what they call truncating, which truncating is just putting those last 3 numbers. You don't want to take the risk of rounding wrong when you've been doing so much math, okay? So your answer is 5.656. And that is your final answer for this question. So for this next question, we do deal with half-life, which I'll go over in a moment. It says 10 grams of plutonium isotopes were released. How long will it take for the 10 grams to decay to 1 gram? So your keyword here is literally what this lesson is called, decay. All right? So let's try and figure out what the ordered pairs are that they're giving me. They say that we started off with 10 grams, right? And 10 grams were released. So my initial, when I first started this scenario, my initial was 0, 10 grams. Okay? Now it says, how long will it take for 10 grams to decay to 1 gram? So that's part of the last ordered pair. The second ordered pair that I need to know is based on the half-life information. So here's what half-life means. It says that it'll take 24,100 years for the plutonium to be half of what it was. Okay? So when time passes to 24,100 years, I will be half of what I was. What's my y? 5. Half of what I was 10. Half of that is 5. Does that make sense? And then the last one they're asking me, a little different than the last question, is How long will it take? So what they're asking me for is time. When will I be 1 gram? If you can figure out your 3 ordered pairs, you're pretty much set for the question. Okay? All right, so again, we don't have to necessarily do our work for C. Whenever I have 0 as my time, it tells me my initial amount. So what is C? Nice. C is 10. Okay? Now I'm going to use my second ordered pair to keep going. All right, to solve for K, 5 equals C, which is 10, times E raised to K times time, which is 24,100. Okay? So my job again is to get that K alone. So step 1, divide the 10. And I have sorry about that. So 5 over 10 is half, and I have E raised to, I'm going to put the number first, 24,100 K. What do I do to start getting that K out of the exponent? Very nice. ln to both sides. It's going to move this 24,000 K to the front. And if I learned anything from my last question, what is this ln of E going to turn into? 1. So I can go straight to writing ln of half equals 24,100 K. Last step. K equals ln of 1/2 divided by 24,100. Oops, too many zeros. Or if you don't want a fraction and a fraction, when you have to type this into your calculator, you could say 1 over 24,100 times ln of 1/2. Either or, okay? Good question. ln of 1/2 is not the same as ln over 2. That would be half of ln. Okay? All right? And now our last step. What is time when my value of the grams is at 1? So unlike the last question, I'm plugging 1 into the y, and I'm solving for time. So I have C, which is 10, times E raised to all of this, which is K, times T. Okay? So my work is going to look a little different on this question. I need to get T by itself. And since T is up in the exponent, my work is going to look a lot like this left side over here when I had to get that K by itself. Okay? So step 1, divide by the 10. So I'm rewriting this whole thing that represents K for the sake of your notes. But if you're taking the AP test and you want to save some time, once you made a claim for what K is, feel free to write K here every time until the very end when you have to plug it in your calculator. Does that make sense? It's a good time saver. All right, what do I do to start getting that T out of the exponent? Nice. ln both sides. We know ln of E is going to equal 1. And now this entire exponent will come to the front. All right. Now, don't be afraid of this last answer looking kind of ugly. To get T by itself, I need to divide this entire coefficient over to the other side, okay? Okay. Take a moment and put that in your calculator. Remember to use your alpha y equals button to create all those little fractions and make it nice and neat. So if you plug this into your calculator, again, using that alpha y equals button, so they let us put in all the fractions. It should look like this. You should have gotten 80,000. And then, oh, did I put an extra 0 in? Yes, I did. Scroll up, press enter. There we go. I'm sorry. That should be our answer. 80,000, 58.467. Okay. And make sure whenever it's a word problem, guys, that you always put your unit of measurement. Okay. So it says years. That's how many years it will take. All right, so our last example says an experimental population of fruit flies increases according, oops, I put too many A's there, according to exponential growth. Our key word there is exponential growth, okay? It says there were 100 flies after the second day, so that's our first ordered pair they give us. So on day 2, there were 100 flies. And then it says, and 300 after the 4th day. So then on day 4, there were 300. Please do not assume that every day there's 100 more flies, okay? Because maybe, remember, exponential growth starts adding a little bit at the beginning and then adding a lot later, okay? And then it says, approximate how many flies there were in the original population. So what they're asking you for is technically C, okay? So you kind of have to work a little backwards for this one. So we have to use the information we have. Let's start setting up equations with the ones we have. So starting with this one, I can say 100 equals C times E raised to T times K would be 2K. All right. I could also say, according to this one, that 300 equals C E raised to time times K, so 4K. All right. Now, for whenever you have two equations with two variables, remember in Algebra 2 how you could do systems of equations and you could do elimination and things like that, or substitution. So we're going to use the substitution method, okay? If I could isolate C, then I can set them equal to each other and solve for the K. So if I want C by itself here, I have to divide by the E raised to 2K. So I have 100 divided by E raised to 2K equals C. Same thing here. All right. Now that I have C by itself on each, well, if C equals this and C equals this over here on the right, then I can set them equal to each other. Okay, so I could say that 100 over E raised to 2K should equal, if they both equal C, then they should both equal each other. And at this point, I could do some cross multiplication and solve for K. So if I cross multiply, I get 300E raised to 2k equals 100 e raised to 4k. Get the numbers on one side and the e's on the other. So I'm going to divide this 100. I'm going to divide it to that side. And then this e, I'm going to divide over to that side. So I have 300 over 100 equals e to 4k over e to 2k. So now I can simplify this left side to just say 3. And on this right side, remember from algebra 2, if I have the same base, I can subtract the exponents. So I could say e raised to 4k minus 2k, which is just e raised to 2k. How do I start getting that k out of the exponent? Nice. ln both sides. Okay. Remember ln of e equals 1, and I could move this 2k to the front. So I have ln of 3 equals 2k. And my last step to getting, I'm going to move on up here so I have some more room. K by itself is divide that 2, and I could say k equals ln of 3 over 2, or I could say half ln of 3. So if you ever feel yourself getting lost in the middle of a question, like, okay, where do I go from now? Reread the question. It said to find how many flies were originally in the population. Well, original, right, means just finding C. And now that I have K, I have the freedom of just plugging K into one of these two formulas to solve for C. Pick whichever one you want. I like working with equations that have smaller numbers, so I personally would go with the left one. So now I could say 100 over e raised to 2 times half ln of 3, and this is going to give me C. All right, take a moment and plug that in your calculator. All right, so if you plugged it in your calculator, it should look something like this. Okay, you plug in that K back in, and you should get 100 over 3, or if you change it to a decimal, and again, you do that by saying math, and then you press number 2, which is DEC for decimal, and then it changes it to 33.3. Okay, now it said this took days, so this would be 33.333 days, okay? And that is your final answer. Sorry, guys. They were asking for flies original. So it's not days. I apologize. It is flies.